talked about quadratics is learning these three methods for solving them. I don't care what method you use. When we have the quiz, I'll probably put one question that I make you complete the square because it is an important skill to have. But completing a square over the quadratic formula, really both of them give you the same answer. It's just which one you like better. I like factoring, I think because when I was in high school, like it was drilled into my brain so much that I just actually enjoy factoring now. But a lot of people don't like factoring because they struggle with the steps and getting it to work out. Factoring only works on some problems, and so that's why if you don't really like factoring, it's not that big of a deal on these because you can always complete the square, you can always do the quadratic formula. And so the questions that I'm going to give you today, the directions say solve by any of these methods. Definitely if it's factorable, it's usually easier to do it by factoring, but you don't have to factor. You can complete the square or quadratic formula on them all. Okay, so I have a couple examples. I'd like to do factoring by grouping with you today just to remind you because it does show up every now and again and people forget over the summer. So it's okay, I'm going to go on here and look at an example. We're going to do just one of these simple factoring ones and then we'll do a harder one. And again, if I ask you to solve this and you complete the square, you're going to get the same answer. But remember that factoring works out really nice if you can remember the rules of it, and it's usually less work to do, just more brain power required. But hopefully, being in precalculus, I hope that we feel good if I asked you to factor this, that this is a trinomial, and we're going to break that up into two binomials, kind of undoing FOIL, if you remember. And you ask yourself, what multiplies give me x squared? It's easy when it's just a letter up there, right? The harder part is when there's a number in front of it. So I say x and x. And then if you just remember what you're looking for here, I always start here and like work my way backwards. You're asking yourself, what multiplies to give me this number that subtracts to give me this number in the middle? And hopefully, let's see, what? 12 would be 6 times 2 gives me 12. And I need a negative 4 in the middle, so if I make minus 6 plus 2, that gives me negative 4. Yes? Remember this or no clue what I'm talking about? Good. That's factoring. When we're solving it, the nice thing is if you can make this multiplication equal to 0, if two things multiply together to give you 0, one of them has to be 0. So that's why we're allowed to separate those and set each one equal to 0. And probably you don't even show this step at this point, and I'm okay with that. Like you just know, oh, that means x equals 6, or what would make this 0, x equals negative 2. And if the zeros are nice integer numbers, then it's factorable. If they cross the x-axis at lovely numbers, then it works. Most of the time, they don't cross at such nice numbers, and sometimes they're imaginary. So that's why factoring only works at times for us. But if you see something's factorable, factor it, if you want. Yeah? Are we okay with that? I'm going to skip the other one here because we're good with this. Now my numbers are all off, that's okay. Let's make this number 2. I want to go through this with you, and then I want to do quadratic formula with you. You just wanted to come back for some precalculus.
Thank you, I'm very excited.
This is where a lot of people not a big fan of factoring anymore because they struggle figuring out what you multiply here and you multiply here. But factor by grouping is a great way that you don't have to really think about it so much. And if you see a number in front, remember you can multiply the first and the last number together. And 3 times negative 1 is negative 3. I picked some pretty small numbers here, but and then you ask yourself, what multiplies to give me this number that subtracts to give me that number in the middle? So it's really just like one extra step. So what multiplies to give me negative 3 that subtracts to give me positive 2, that would be 3 is a prime number. It has to be 3 and 1, right? And this is where we put the x's back with it because we're trying to rewrite that middle number to two numbers, and add or subtract to give you that. And the only way we can put 3 and 1 together and get a positive 2 would be if the 3 is positive and the 1 is negative. And then you bring down the first and the last. So basically what we've done is we've broken FOIL back out into 4 things. Because if you think about when you multiply a binomial, you can always combine the middle term. So this is the F, this is the OI, this is the L. When we do factor by grouping, we actually break it back down into the FOIL. So that's really what we're doing. And when you do that, you can now do factor by grouping. You can group these two together and say, oh, they have a common factor now. I can take out a 3x, and I'm left with x plus 1. And look what's left. We want those to be the same in parentheses. So when I see that these are both negative, and I want them to be both positive, I see that I could take out a negative 1 from both of those, and I'll be left with x plus 1. Vague memories of this process? No? Yes? And the last step, I always do this opposite from most of my students, I don't know why, but I always factor out what's the same, and they tend to always put together the 3x minus 1 first. But really what we're doing is we're taking out the x plus 1s because they're the same. So if you take those out, what's left is 3x minus 1. And if you multiply that out, you get back that original.
It doesn't matter what order they go.
It doesn't matter. That's why you can write them any way that you want. Because if you write 3x minus 1 times x plus 1, you're going to get the exact same answer. Oh my gosh, I'm not even done yet because I just factored. I actually have to solve these now equal to 0, right? And this is where a lot of people are going to choose completing the square or quadratic formula, and I'm fine with that. There's not going to be any on your quiz from this chapter P that I require that you factor. I just like to remind you of it. But if we solve this, we're going to get x equals negative 1, and if we add 1 and divide by 3, we're going to get x equals 1/3. And I believe there are a couple on the quiz, not the quiz today, the paper that I'm giving you today that you could factor if you want, but no requirement there. Completing the square we did already, so I'm not going to go over that again. But I do want to remind you of the quadratic formula. Maybe you have the quadratic formula memorized. Every year in calculus, I have students that have forgotten the quadratic formula. But if you complete the square from this, like if you proved using completing the square from this, so if we divided everything by a first, and then we took half of b over a and we squared it, like if we did completing the square with this formula right here, that's where the quadratic formula comes from. I'm going to save you that because I don't feel like you really care that much about the proof of it, but that's where it comes from. That is the formula. If you're going to use the quadratic formula, you got to know it. There will be no point in this class that I ever let you write down the quadratic formula before a quiz or a test. Does our clerk sing a song to you to teach you the quadratic formula? Does Bai sing a song to you to teach you the quadratic formula? We're missing out on life skills.
Sing us the song.
I do sing a song. Mr. Mullis, did you? None of you had Mr. Mullis, did you? He sings a song. There's a song for some fight song. I don't know. Notre Dame fight song. I don't know that. Trevor, do you know the song? I don't know the Notre Dame fight song one, but I do know 2 songs. One is To Pop Goes the Weasel. And so you have to kind of think about the tune, like, all around the mulberry bush, x equals negative b plus or minus radical b squared minus 4ac all over 2a. Not that good. And then there's one that I always thought was a song, Do Your Ears Hang Low, from back in the Barney days, you know, the big dinosaur, like, do your ears hang low, do they wobble to and fro, can you tie 'em in a knot, can you tie 'em in a bow? But apparently there's some song like, do your chain hang low. I don't know this song, but apparently you can do that too. But it goes like this. Due to a hang low under negative b plus or minus square root b squared minus 4ac. If you practice your quadratic, you will know it automatic. Due to a hang low. See, look, you would know it. I try to teach my 5-year-old that song, but he doesn't think it's quite cool enough yet. So someday I'm going to get him to sing it, but before he realizes it's too dorky to sing. There's a very fine line between there. Know it. right? So let's do one of these together, and then I'll leave you alone. Mr. McClure will never sing a song. Ever. Every year for Pi Day, I try to convince him, and he just laughs at me. And Mr. Stewart, I don't know how we can't get him in there either. He won't sing. I'm hoping this year, now that he's right across the hall, I'm hoping I can influence him. We lost a big Pi Day participant when Mr. Mullis left us. You could do completing the square here. It wouldn't be that bad to do. You could divide everything by 3 first. But a lot of people don't like dealing with those fractions, and so that's where a lot of people, if the middle number isn't nice and even, or if they have to divide, that's where a lot of people use the quadratic formula. And the nice thing is it's just a formula. We're just going to plug it in. So x equals negative b, I won't sing anymore, plus or minus the square root of b squared minus 4ac all over 2 times a. My advice is, if you're using the quadratic formula, show me some sort of work, because if you do all the math in your head and you get the wrong answer, I have no clue if you even had the formula right. And so you don't have to show me every little step in between, but show me something so that I can see that you at least knew where to start. Watch your negative signs here. So this is 12 and 2 is 24, and that's a negative and a negative, so that's 81 plus 24, which is 105. Is that right? What a mess. And so again, a lot of people like the quadratic formula because they don't have to remember really steps. You just have the formula. From here is all about simplifying, and that's where people make their mistakes. Radicals, you want to simplify if you can. The square root of 105 is not a perfect square, but you do want to take out any perfect squares that could go in there. I don't think anything goes into 105. No, it's odd, so 4 is not going to go into it. You know the trick to how to tell if 9 goes into a number? If you add up all the digits and they add up to a multiple of 9, then 9 goes into that. Did you know that? You just learned something new today. So 7, I don't have a trick for 7. I just have to check it, but I don't think 7. And 7's not a perfect square anyway. But. Same thing with 3. If you add up the digits of a number and if they're divisible by 3, then it's the number divisible by 3. Divided by 49. Yeah, it doesn't work. So that's good. One thing I do want to say, let me just pretend that this is what we got. What if we got 6 plus or minus the square root of 10 all over 2? People really want to simplify that because they're all even numbers and they really want to take a 2 out of everything. But that's a square root of 10. So just remember that you cannot cancel something out inside of a square root with something outside of a square root. So if this was my answer, I can't simplify that anymore because I can't just divide the 6 and the 2, and I can't cancel out the 10. You with me on that? If there was like a 2 in front of that 10, then we could do that. That's probably the biggest mistake that I see when it comes to quadratic formula and completing the square. So that's all I have for you today. I have a worksheet for you to practice some of this fun stuff that you have done all summer. And since it is a worksheet, that means it's not on your assignment sheet, which means it's actually due tomorrow. So if you like to slack off on your homework, don't slack off tonight, because we will turn this in tomorrow. And notice the directions say you can do factoring, completing the square, or the quadratic formula. Some of them are not factorable, so the estimated factoring is not going to work on all of them. And I will tell you that number 6 is kind of a crazy hot mess compared to the rest of them. So if you get some crazy answer on number 6, there's a good chance you're probably right. Okay? So I'm actually giving you the rest of the time to work on this, so if you need help, let me know, and you good chance you'll get this done, and you won't have to work. Yes.
First slide back up there.
Yes. Sorry. If I ever skip a slide before you get it written down, just tell me to go back because, oh my gosh. maybe I can go back. Because I don't know how long it takes you to write stuff down.